Hello friends, today we are going to discuss about C storage classes. Now we are familiar that every variable in C programming has two properties, type and storage class. Type refers to the data type of a variable and storage class determines the scope, visibility and lifetime of a variable. So what is scope of the variable? Its visibility and lifetime is indicated by the storage class of a variable. There are four types of storage class: auto storage class, external storage class, static storage class, and register storage class. Now let us discuss each one by one. First, auto storage class. Auto stands for automatic storage class. The variable defined using auto storage class are called as a local variable. A variable is in auto storage class by default if it is not specified. The scope of an auto variable is limited with the particular block only. Once the control goes out of the block, the access is destroyed. This means only the block in which the auto variable is declared can access it. A keyword auto is used to define an auto storage class. By default, an auto variable contains a garbage value. Let us see an example. So using this statement, we declare an integer variable s, and here we are using the auto keyword. So this is is its class is storage class is auto storage class. The program below defines a function which has two local variables. In this one, this function add, we declare two variables a and b. Now, while declaring the variable a, auto keyword is not used. So here this a is not declared explicitly in the auto storage class. But even though we are not using the this auto keyword, this is in default class is the auto storage class. In the second declaration, auto keyword is used, that is variable b. Its storage class is explicitly defined using the auto keyword. And when this function is called in, it returns the sum of a and b. Below program shows the scope level, visibility level for auto variable in each block code, which are independently to each other. Now, if we have a program like this one, in this program, in each block, this program has seen three blocks, and in each block, name of the variable is same. But as the local variable or auto class variable is visible only in that block, that's why whenever this function is run, we get the output like this one, 3 2 1. Now whenever inner block in which value of j is initialized 3 is executed, that is using the printf, we print the value of j as a 3, and after executing the inner block, when control comes out this block, then out of this block, here we are having auto int j equal to 2, that is value of j is initialized to 2. So whenever printf statement is executed, we get the value of 2. And again, after executing this printf, we come out of the outer block of it one, that is first outer block. And in the this first outer block, we are having auto int j equal to 1. Again, variable name is the same, but it is declared in the auto storage class, and here its value is 1. So it gets printed using the printf function, and here we are having a value of 1. So from this program we find that value of 3 is printed using the innermost block in which variable j is declared in the auto storage class. Then second innermost variable, value of variable j is again declared with the same name, and again it is in the auto storage class. So that value gets printed, and finally in the outest block, value of variable j is initialized as a 1, and so we get here 1. Output is 3 to 1. So from this program we see the visibility of the variable, that is this auto storage variable has visibility only in which it is defined and declared. Next one is the external storage class. External stands for external storage class. External storage class is used when global functions are variables which are shared between two or more functions or files. So whenever variables are to be shared between more than two or more functions or two or more files, we declare the variable in external storage class. Keyword external is used to declaring a global variable for R function in another file or function to provide the reference of variable or function which have already been declared. The variable defined using the external keyword are called global variable. These variables are accessible throughout the program. Let us see an example. In this program, void display, here we are declaring a function display, and then int n equal to 5. A external variable, or we can also say that a global variable n of integer type is declared, and it is initialized to a value of 5. Then in function int main function, value of n is incremented. So here this n has already been defined and declared as an external variable or global variable. Its value is incremented, so its value becomes 6. And then next statement is function called display. So next function display is called in, and what is the function of this display function? That is plus plus n. Value of n is again incremented, and again see that this variable is not declared inside this one, so we can use global variable in any function in the program. This variable can be accessed by any function in the program, and so we are accessing or using the variable n in main function as well as display function. So value of n is incremented, so its value become from 6 to 7, and using the printf function this value gets printed. So through this program we see that a global variable which is defined and declared outside of any function can be accessed by any function in the program, and when we run this program we get the output as a 7. So explanation is again given here. Suppose a global variable is declared in file 1. So instead of two function in a program, if we are having the two file in which this global variable is declared, then we can access the same variable in the another file. If you try to use that variable in a different file too, the compiler will complain. Now to solve this one, keyword extra is used in another file that indicate that this variable is declared in some file that can be used in the another file. So we have to use the external keyword, and this can be seen in this program. Using this program, in this program we are having the two files. First file is original.c. Name of the first file is original.c. In this file we are having two statements. Hash include standard input output.h. That standard input output.header file is included, and then we declare a variable I equal, and its value is initialized as a 48. So this this variable is declared outside of any function inside the file. So this becomes the external variable or global variable. Now whenever we run the second file in which main function is there, here we are using the external I. Now this external I is external keyword is used just to indicate that this variable has been declared in another file. It has been defined and declared somewhere else. And in main function printf, value of external integer is equals %d. So at this point value of I gets printed, and value of I is 48. It is defined, it is initialized in the variable in the file original.c. So that value gets printed at this point. So when we run this program, we get value of the external variable is 48. So here we see that whenever a variable is defined and declared using the external storage class, while using that variable in another file, we have to use the external keyword. Now let us see the static storage class. The static variable are used within function or files as a local static variables. They can also be used as a global variable. A static local variable is a local variable that retains and stores its value between functions call or blocks and remains visible only to the functions or blocks in which it is defined. Static global variables are global variables visible only to the file in which it is declared. Example, here static int count equal to 10. Let us see an example. In this example program, here in main function, here void function 1. In function 1, here we declare the two variables int x is equal to 20, static int y equal to 30. So y is declared as a static integer variable. Where is a int x? X is declared as a local variable. And after that one, x is equal to x plus 10. Value of x is incremented by 10 and value of y is incremented by 10. Print f percentage d x y. So value of x, y is printed at this point. But this function, when does this operation, when it is called in the main function. And in main function, because execution of the program always starts from the main function. So when first time function 1 is called, what would be the output of this one? Output of this function would be value of x and y. After incrementing the value of x equal to 20 and y equal to 30 by 10 gets printed. So value of x becomes equal to 30 and value of y becomes equal to 40. So value of 30 and 40 gets printed. When we call the same function second time, so when this function is called second time, so during the second call, value of x is assigned to the value of 30, and when its value is incremented, it becomes 20 plus 10, that is 30. But in case of the variable y, because it has been declared as a static type, its previous value, that was 40, is written, and 40 plus 10, that is 50, gets printed. So 40 and 50 would be the output when this function is called in, and when third time is called, this 50 is retained by the variable static variable y, and when it is added by the 10, its value becomes 60. So we get the output of this way: 30 40, 30 50, 30 60. In the example, local variable will always print the same value whenever function will be called, whereas the static variable will print the incremented value in each function call. So from here we can understand what is use of declaring any local variable as a static. Now let us see the another example. In this example, we are using two functions. One is the main function, another is the void function. So whenever a void function is called in, and also in this program we are declaring a static global variable counter, and its value is assigned initialized to 7. In next function we are declaring a static local variable and its iteration, and its value is initialized to 13. So whenever this program is run, we get the output of this nature. So again, whether it is a global static variable or local static variable, they have they, their previous value retained. So that's why we get the output of this nature: iteration equal to 14 and counter is equal to 7. Iteration is equal to 15 and counter equal to 8. So here indicate the advantage of declaring global variable or local variable as in the static storage class. The global static variable are accessible throughout the file, whereas local static variables are accessible only to the particular part of the code. The lifespan of static variable is in the entire program code. Now, last one is the register storage class. So you can use register storage class when you want to store local variable within function or blocks in CPU register instead of RAM to have a quick access to these variables. So if you want to store any data in CPU register for quick access, we have to declare that variable as a register storage class. For example, counters are a good candidates to be stored in the register. So any variable used for counter purpose should be declared as a register storage class. For example, register int age. So here we use the keyword register to declare any variable as a register storage class. The variable declared using the register storage class has lifetime throughout the program. It is similar to the auto storage class and limited to the particular block only. The variables declared using register storage class are stored inside CPU registers instead of memory. So whenever any variable is declared in register storage class, this variable or data corresponding to this variable is stored in the register of the microprocessor. Register has the faster access than that of main memory. The variables declared using the register storage class has no default value. These variables are often declared at the beginning of a program. So here an example is given. Register int weight. So this variable weight is declared in the register storage class, and whenever this program is run, so here mention is that it produces an error when the compilation occurs. We cannot access the memory location when dealing with the CPU register, and here we are pointing to the memory location to store the value of weight, and that's why an error is produced. So this output error address of the register variable weight is requested, and this is the error while this program is run. Now complete C storage classes, whether it is auto, register, extern, static. All has been charted here for the brief review of this one. So at this point we end our discussion. Till next class, bye and have a nice day.